Hi guys, this is Vineet and I welcome you to this video. Today's video topic is disk space requirements for Index DDL operations. This will be a theoretical session and today we will discuss on any of the disk space requirements that are needed for any index data definition language operations. Before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding my upcoming and future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I will be creating on indexes in the coming 15 to 20 days. In next 15 to 20 days, the indexing topic will get covered completely. So yeah, it's very much essential that you watch all the videos on indexes that I will be releasing during this next 15 to 20 days period, 15 to 20 days period. So please subscribe. There's a subscribe button below this video. Click on that subscribe button and follow the process. And I'm giving you 5 seconds. Please go ahead and do so right away. So guys, I hope you must have subscribed by now. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share in your comments and stories and also your suggestions as well. We eagerly wait for your comments and suggestions, so please do share them as we would love to read them. We have created some playlists for you to watch. Some of the popular SQL Server playlists are SQL Server database design, tables, business continuity, indexing, performance tuning, integration services, and Project SQL. And if we talk about this video pertains to the SQL Server indexing category, which has more than 20 videos at present, and the list is growing eventually day by day. And if we talk about the total number of videos posted on our channel, we have more than 240 videos posted on our channel. The count is soon reaching the 250 mark. We will let you know once that mark is reached. Apart from that, I have a channel page link which is given at the bottom of this page. Also guys, the link for all these playlists and the channel link page link is given in the video description area of this video, so please check out the video description area and go to various playlists to figure out what all videos they have. And if you want to learn about a particular domain, what we would suggest is go to that particular list and watch out all the videos from beginning till the end. The reason we create playlists for you is that because it simplifies the learning. Instead of watching videos randomly, you can go to a particular area or domain which basically catered by particular playlist. So for example, if you want to learn about SQL Server indexing, you may go to SQL Server indexing playlist and watch out all the video from starting till the end to gain better clarity in that area. Alright, let's come back to today's topic where we will have a discussion on disk space requirements for Index DDL operations. So let me quickly take you to notes. So today's video topic is disk space requirements for any index data definition language operation. So disk space, if we talk about, it's an important consideration whenever you create, rebuild or drop any indexes. Inadequate disk space, so for example, if you don't have sufficient disk space, this can degrade the performance of these operations, which is create, rebuild or drop indexes. If you don't have sufficient disk space available, it can degrade the performance of these operations and it can even cause the index operation to fail. Now in this video, we will discuss about how you can determine the amount of disk space required for index data definition language operations. Not exactly in this video. This will again be a 3-part series, I would say. So in the third part, we will be basically discussing about how you can calculate amount of disk space required. So guys, that's the reason I'm asking you to subscribe. Please go ahead and subscribe right away. I don't want you to miss on any of the parts. Otherwise, you will not be able to catch the whole topic. So please go ahead and do so. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. Now let me proceed ahead. First of all, let's talk about any index operations that do not require any additional disk space. So following are the index operations that for which we don't require any additional disk space. So what are these operations? If we perform any alter index reorganize operation, this does not require any disk space. However, log space is required. So disk space in a primary database file group is not required, but in the log file, the disk space is required. And if we talk about the drop index operation where we just delete the index, so whenever you're dropping the non-cluster indexes, this does not require any additional disk space. So no issues when you drop the non-cluster indexes on a table. This does not require any additional disk space. Whenever we are performing the drop index operation, whenever we are dropping a cluster index in case of the non-cluster index, and whenever we are dropping a cluster index in an offline mode, and the offline mode is where the index is not available to users. Even in case of cluster indexes, if we are dropping in the offline mode, the table will not be available. The underlying table will not be available for querying purpose to the users. So whenever we are dropping the cluster indexes offline without specifying the move to clause, so sometimes while dropping the cluster index, we do specify the move to clause if we want to move that cluster index to a target location. So we are not specifying that move to option while dropping the cluster index in an offline mode. And also if the non-cluster indexes do not exist, then we don't require any additional disk space. So we are not moving, if we are not specifying the move to clause, we are not moving cluster index to anywhere, and we are just dropping the index. For dropping purpose, there is no need for additional disk space. And if there are no non-cluster indexes present on the table, then yeah, definitely we don't require any additional disk space. Now the fourth option is whenever we are creating a table with a primary key or unique constants, this does not require any additional disk space for any indexes that are created in the background due to the creation of the primary key or unique constraints. Now let's talk about the index operations that do require the additional disk space. So we will be discussing about various index operations that require the additional disk space. So all the other Index DDL operations, apart from these four operations, require additional temporary disk space to use during the index rebuild operation. And permanent disk space is also required to store the new index structures or structure. Rebuilding an index requires the additional temporary disk space as well as the permanent disk space to store any new index structure. The temporary disk space is needed for any sorting purpose, whereas the permanent disk space is required to store the new index structure or structures. Now, when a new index structure is created, disk space for both the old structure as well as the new structures is required in the appropriate files and file groups. So whenever we are creating a new index structure, let's say for example, let's take a rebuild operation where we are rebuilding an index where an old index already exists on the table and we are rebuilding a new index. So in that case, disk space is required for both the old structure as well as the new target structure, and this disk space is required in the appropriate files and file groups. The old structure is not deallocated, so the old structure does not get deleted until the new index structure gets created or the new index creation transaction commits. Until the new index creation transaction commits, old structure remains in place, so that's why we need the disk space for holding both the old structure and the new structure at the same time. Now the following index DDL operations create the new index structures and will require any additional disk space. So whenever we are issuing a create index statement, we need additional disk space. Whenever we are issuing a create index statement with drop existing index, we definitely need additional disk space. Alter index rebuild statements also require additional disk space. Alter table add constraint, whether it's primary key or unique constraint, require additional disk space. Alter table drop constraint, whether we are dropping or dropping a primary key or unique constraint, when the constraint is based on the cluster index. So whenever we are dropping these constraints, whether it's primary key or unique constraint, and when these constraints are based on the clustered index, then yeah, we definitely need some additional disk space whenever we are dropping the constraint. And whenever we are dropping an index with the move to operation, we do need additional disk space, and this applies only to the cluster indexes. Now earlier we were talking about we both need the temporary disk space and the permanent disk space, and I was telling that temporary disk space is required for sorting purpose. So here we are discussing on that elaboratively. So we need a temporary disk space for the sorting purpose. Now, beside the disk space required for source and the target structure. So in addition to this disk space, which is a permanent disk space required for holding any source and target index structures, we also do need the temporary disk space. So temporary disk space is required, and this temporary disk space is required for any sorting operation unless the query optimizer finds an execution plan that does not require sorting. So in case the query plan requires the sorting, then yeah, we may need the additional space for the additional temporary disk space for the sorting operation. And otherwise, if the query optimization plan does not require any sorting operation, then yeah, we don't need the temporary disk space for any sorting operation. Now, if the sorting is required as per the execution plan, sorting occurs one index at a time. So the sorting doesn't take place parallelly on all the indexes. So only one index gets sorted at a time. So if a sorting is required, only the one index gets sorted at a one new index gets sorted at a time. For example, whenever we rebuild a cluster index, so whenever we are performing a rebuild operation on a cluster index and the associated non-cluster index. So here we are taking an example of a table which has a cluster index as well as many other non-cluster indexes as well. And whenever we are performing the rebuild all operation on this table, where we are rebuilding both the cluster index and the associated non-cluster indexes within a single statement, the indexes are sorted one after the another. If you perform this kind of operation, only one index gets sorted at the time. Therefore, the additional temporary disk space is required for this sorting operation, and the space amount of space required, it should be as large as the largest index in the operation, because we are sorting only one index at a time. So this space should be large enough, equivalent to the largest index in the group, and this is almost always the cluster index, which is the largest index. So we need temporary disk space equivalent to the size of the cluster index here. Now, if the sort in tempdb option is set to on, if this set option is set to on, the sorting takes place in the tempdb. The largest index must fit into the tempdb. So if this option is on and sorting is required, we need the amount of disk space in this tempdb files equivalent to holding the largest index that must fit into the tempdb. Although this option increases the amount of temporary disk space that is used to create an index. Although turning on this option will require increase the amount of disk space that is required to create an index, it may reduce the time that is required to create an index. So creating index with the sort and tempdb option set to on is a faster operation, because sorting takes place in tempdb, and if we have tempdb files placed on another disk, then yeah, it will provide us some performance benefits, so that index can be created quickly. So it may reduce the time that is required to create an index when tempdb is on a set of disks different from that of a user database. Now, if sort in tempdb option is set to off, so if this sort in tempdb option is set to off, where does the sorting take place? So if this option is set to off, which is the default, each index, including any partitioned indexes, is sorted in the destination disk. So in case this option is set to off, the index gets sorted in the destination disk where they have to be created or rebuilt. So they get sorted in the destination disk space, and only the disk space for the new index structure is required. And we only need the disk space for the new index structure. Let's talk about temporary disk space for online index operations. So if we are doing any online index operations, so in the online index operations, the index remains online and user can query the tables if the index is online. Otherwise, if we are taking the index offline, user will not be able to query the table at that time, especially in case of cluster indexes. So we are talking about the temporary disk space required for any online index operations. Now, whenever you perform the index operations in online mode, additional temporary disk space is required at that time. Now, if a cluster index is being created, rebuilt, or dropped online, so if we are doing the creation, rebuild, or drop operation on the cluster index in the online mode, a temporary non-cluster index has to be created to map the old bookmarks to the new bookmarks. So we are dropping an index or creating an index or rebuilding an index. A temporary non-cluster index is required or is created to map the old bookmarks to the new bookmarks. And if the sort DB option is set to on, this temporary index is created in the temp DB. We are talking about this temporary non-cluster index. So if that sort in temp DB option is set to on, this temporary index gets created in the temp DB. And if it is set to off, if this option sort in temp DB is set to off, the same file group or partition scheme as the target index is used. Now the sort and temp DB option cannot be set for drop index statement. So this cannot be set for any drop index statements. The temporary mapping index is always created in the same file group or partition scheme as the target index for any drop index. Now online index operations use row versioning. So this is one of the other features on which I have to create the video. So whenever we are using the online index operations, which basically use the row versioning technique to isolate the index operations, and basically it uses the row versioning technique to isolate the index operations from the effect of the modifications made by other transactions that are coming from the users. So basically row versioning is used to isolate the index operations from the effects of the modifications made by the other transactions triggered by the users. Now this avoids the need for requesting the share locks on rows that have been read. So we don't need any share locks on the rows that have been read for rebuilding a new index. And concurrent user update and delete operations can occur during the time online index operations. So concurrent user update and delete operations during online index operations require space for storing the version records in the temp DB. So this is the additional disk space required. So if the users are triggering any updates and delete operations during the online index rebuild operation, this may require additional space for storing the version records in the temp DB. So guys, we are done with this video. I hope you like the content of this video. Today we have discussed on the disk space requirements for the Index DDL operations. We have discussed about this, and we have talked about index operations that require no additional disk space. After that, we have talked on index operations that do require additional disk space. Finally, we talked on the temporary disk space for the sorting purpose that is required, and in addition to the permanent disk space required to hold the index structures, we also do need the temporary disk space. And lastly, we talk about the temporary disk space for any online disk operation, online index operations, because if we are performing an online index operation, we need some additional space to store the temporary non-cluster index that gets created in the background. Guys, in our next video, we will talk about the transaction log disk space requirements for any index operations. And finally, we will show you the disk space example in our third video, where we will show you how you can calculate the amount of disk space, any disk space required. So how do we perform such calculations? We will talk on that. So stay in tune and do subscribe to my channel. If you really like this video, click on the like button below this video, guys. And guys, if you're new to this channel or if you haven't yet subscribed to the channel, I would highly recommend please go ahead and subscribe to this channel right away. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the index videos that I will be creating during next 15 to 20 days. And this is also a 3-part series which I'm discussing right away, which is a disk space requirements for any index operations. So next video we will be creating on the temporary disk space required for the Index DDL operations, and there are three-part series, and I don't want you to miss on any of the parts, so it's very much essential that you subscribe right away. So go ahead and subscribe. There's a subscribe button below this video. Click on that subscribe button and follow the process. I'm giving you 5 seconds. Please go ahead and do so right away. So guys, I hope you must have subscribed by now. If you have subscribed, I would urge you to please post in your comments and suggestions and any reviews. Do also let us know about your stories related to SQL Server. And guys, we eagerly wait for your comments and suggestions, and we do love to read them. So do post in your comments and suggestions. And guys, if you have good network of friends, please share my videos with your friends. There is a share button below each and every video through which you can share my videos on any of the social media platforms with your friends. So do share my videos with your friends in case they work in the SQL Server domain, and also ask your friends to subscribe to my channel in case you feel my videos can make difference in their life. Then yeah, you can help them by asking them to subscribe to my channel. I thank you so much for your time on this video today, guys, and you have a wonderful day ahead.